Okay, we are going to continue chapter number 4, network layer, the data plane. Okay, so we have discussed the IP internet protocol, its header format, and how fragmentation is performed, and and we have discussed a little about somehow about IP version 4 addressing scheme. Okay, in today's topics, we include IP version 4 addressing. We will continue IP version 4 addressing, and we will also discuss DCP and NET protocol. Now, I would like to emphasize specially that why we use the subnet mask. As we have discussed that in a network, the IP addresses, they are assigned to the host consecutive IP addresses are assigned to the host in a network. For example, you can see here that this is a subnet, or this is a network, and it contains the host. It contains the IP addresses 223.1.1, 223.1.1.2, 223.1.1.4, 223.1.1.3. So you can see that in these IP addresses, the first 3 bytes, that is 223.1.1, it is common in each and every host IP address. So this is called the network number. As we have discussed that in the seeder, the network part or the host bit, it can be specified arbitrary. That is, for example, in the classful addresses, we had IP addresses that were specified. For example, the first byte in the IP version A, IP address A, and the IP address B, the first 2 bytes were network parts. But in the seeder, they are not like 1 byte or 2 bytes, so they can be any number of bits. For this purpose, we were using the /24. This /24, it specifies that the first 24 bits, they are for network parts. So specifying the when we assign an IP address to a system, and we specify that this is the IP address of the system. However, the first 24 bits, that is /24, it represents the first 24 bits, they are used for network part. So instead of representing the network part in IP address by using /24, we use another scheme, and that is called the subnet mask. Okay, so how the subnet mask is computed for an IP address. So basically, if suppose this is the IP address, for example 223.1.1.1, and the first 24 bits, they are the network part, and the last 8 bits, they are host part. So subnet mask of an IP address can be computed by setting the network bits to 1. All network bits, that should be set to 1. So you can see that the first byte, it is set to 1, the second byte, it is set to 1, the third byte, it is also set to 1. So, and the host bits, all the host bits, they are set to 0. So these 8 bits, these 8 bits, that is the last byte, it is set to 0. So now this is the binary representation of subnet mask for this IP address. Okay, now the decimal representation of this subnet mask can be that this is equal to 255, this byte is equal to 255, this is equal to 255, and 0. So instead of specifying that the IP address of host this, that 223.1.1.1/24, that this is the IP address, and this is the 24 bits are the network part. So we can specify this IP address in that this is the IP address 223.1.1, and this is the subnet mask. So this IP address and subnet mask, these two things, they are equivalent to this representation 223.1.1./4. So this is a little bit easy to compute. Okay, easy to compute. Similarly, if we receive now we have discussed that how the subnet mask of an IP address can be computed. Now if we have IP address and subnet mask, and we want to know that what is the network number. For example, you can see that here the network number for these IP addresses, it is equal to 223.1.1 */24. Okay, so how this network number is computed? Okay, so this network number can be computed from the if we have IP address suppose 223.1.1.1 and subnet mask 255. So it is very easy to find the network part of an IP address this given subnet mask. So we have just to perform the AND. Subnet mask is AND with the IP address. The IP address is AND with the subnet mask. So you can see that this is the IP address, this is the binary representation of this IP address, and this is the binary representation of its subnet mask. So if we AND these two the IP address and the subnet mask, then we will get these values. Okay, so this representation is equal to 223.1.1/0. so this is the 223.1.1. it is the network part. This is the network part. So in this slide what we have discussed, that if we represent an IP address for any machine, so we have to specify that how many bits are network bits. So one way is that we can specify 223.1.1.1/24. So with the /24 we specify that this is the IP address and first 24 bits are the network part. Another way of assigning the IP address is that we specify the network IP address like the IP address like this way and its subnet mask. So this IP address and subnet mask, they both are equal to this representation. Okay, so I think it is much easy to understand. Okay, now as we know that for in order that the two hosts they can talk to each other or they can communicate with each other over the internet, it is necessary that both hosts should have an IP address. Why? Because the IP address basically identify a host. Okay, now how the IP address is assigned to a host. So how an IP address is assigned to a host? So basically, to assign an IP address to a host, we have two types of approaches. One is called hard-coded, or it is also called manual. It is done by the system administrator. Okay, so how it is done? So I have window. So I would like to show you through in my computer system. So if you can go to desktop setting, so this is the you can see if you click on it, so you can open a network sharing. So change adapter setting, so you can go to here. Okay, you can go to properties. Okay, so you can see that there are two approaches. One approach is to obtain IP address automatically. This is to obtain IP address automatically, and this is use the following IP address. So this is the manual approach. For example, if you click on here, so this is you can assign IP address, for example 225.223.1.1/1, and suppose subnet mask is this one, default gateway 1.1.1.1 suppose. Okay, so you can also specify DNS addresses manually. Okay, so this is the manual approach. Another approach is that we use this one approach, that is to obtain IP address automatically. So how in a host get IP address automatically? For this purpose we use a protocol that is called DCP. So now we are going to discuss this protocol. When we click that to obtain an IP address automatically, it basically invoke the DCP client, the DCP protocol. So now we are going to discuss that how DCP protocol gets the IP address automatically. Okay, so another method is that that we get the IP address automatically. For this purpose we use a protocol that is called DHCP. D means dynamic, H means host, C for configuration protocol. So it basically assigns or it enables a host to dynamically get the IP address from a server. So it is a basically plug and play. Okay, So before discussing that, how the basically we have discussed that the DCP, it allows a host to dynamically obtain its IP address from the network server when it joins the network. So we will discuss these things in detail. But before we're discussing these things, we would like to discuss the working of DCP through an example. So in DCP protocol, we have four types of messages: DCP discover, DCP offer, DCP request, and DCP acknowledgement. Okay. So the DCP discovery message, it is used by host to broadcast. Okay. So we will like to discuss these messages through an example. Suppose that this is the client, okay, a host, a laptop. It wants to join the network. That is, before joining the network, it should get the IP address. Okay, so it should get the IP address of this range. Okay, so to get automatically this IP address, we have a DCP server in the network. Okay, this DCP server, it maintains the list of IP addresses that are assigned and the list of IP addresses that can be assigned. Okay, and it also contains the DNS address for this network. It also contains the default gateway in this network. Okay, so what is default gateway? Basically, you can see that when this host wants to send a data to any host that is in this network, so it can have the route to that network automatically. Okay, okay, it knows. But when this host wants to send data to a host that is in another network, for example this host, then this host doesn't know. It only knows the host within its network. Okay, so in this case, if it wants to send data to this host, so it doesn't know that about this node, that whether it exists, that where it exists. Okay, so in this case, it will send the data to its default router, default gateway. This is router, and this gateway or router, it is connected with the rest of the network, so it knows it. So for this purpose, the default gateway is used. Okay, so this DCP server, it basically has two lists. One list is the IP addresses that are already assigned to the host in this network. Another address that can be assigned to any other. Okay, the DNS address, because we have discussed that when we assign an IP address to machine, so we also assign the IP address, the subnet mask, and the default gateway and the DNS. So all these information are stored here. Okay, so when this client arrives, okay, and it wants to get IP address automatically, so it has to enable or invoke the DCP client. Okay, so the DCP client, how it is enabled? When we click on to obtain IP address automatically. So the DCP client is implemented in each and every client and in every operating system, like it is a Windows or it is a Linux, etc. Okay, so when the DCP client is enabled, so let's talk that how DCP client communicates with the DCP server to get the IP address. Okay, now as we have discussed that this DCP server, it is listening on this IP addresses. Okay, it has the IP addresses. These are the IP addresses that are free. It has the DNS address that should be assigned to a host. It has the subnet mask for these IP addresses, default gateway, and all these things. Okay, and it also have that these IP addresses are already assigned to other machines, so these IP addresses should not be assigned to anyone else. Okay, so when the client arrives, so the client doesn't know that where is the DCP server, what is the DCP server. Okay, so because this is just joining the network, so in this case it will broadcast a DCP discovery message. DCP discovery message means it is basically broadcast. Why broadcast? Because it doesn't know that who is the DCP server. Okay, or where is the DCP server. So it will broadcast the DCP discovery message. This DCP discovery message means that is there a DCP server? Is there a DCP server present or not? Okay. Now, what is the format of this DCP discovery message? You can see that the source IP address will be 00. Why? Because this is the source, and this doesn't have IP address yet. It has not, so it wants to get IP address, so it will have IP address 00. This is the port number of the DCP client. The DCP client, it always start on port number 68. We have already discussed in chapter number 1 that some ports are standard up to 1024. These ports are standard. Why? Because they are somehow assigned to the predefined protocols. Okay, they are predefined, assigned to the protocol, central protocol. And the destination IP address will be network broadcasters 255.255.250. Why? Because this doesn't know that who is the DCP server, where is the DCP server, because it just want to join the network, so it doesn't know about the network. So it will set the destination IP address 255, that it is for each and every machine. Okay, and this is the standard protocol for the DCP server. Okay, 67. We will discuss this why IP address, and we will discuss it later on. This is 00. It represents that the client doesn't have any IP address previously. Okay, 00. Transaction ID. Whenever a DCP client sends the message, so it assigns a transaction ID. This is the identifier of the message. This is the identifier of the message. Okay, so it is basically broadcasted. When it is broadcasted, so it will be received by all the nodes in the network. You can see it will be, when this message is broadcasted by this machine, so it will be received by this machine, by this machine, by this machine, as well as by the DCP server. Okay, so you can see that the DCP server is only running on this machine. So here the port number 67 will be running on these machines. These will accept the message at the network layer, but at the transport layer this message will be discarded. Why? Because the DCP server or the port number 67 is not open on this machine, and this and this. It is only open on this machine, so only this machine will accept the message at the transport layer. At the network layer it will be accepted by each and every host. Why? Because the DCP discovery message has the address 255, 255, 255. This is the broadcast address. It is the address for each and every one. Okay, it is for all, the message is for all. But at the transport layer the port is 67, so this is only for DCP server application, and the DCP server application is only running on this server, not on other machines. Okay, so you can see that when this message broadcasts, this will be received by the DCP server. So when it receives this message, the DCP server application, it will examine it. Oh, this is the DCP discovery message, so it means that the client wants to know about DCP server. So this is the DCP server, so it will respond. It will respond with what? First it will respond with its own IP address, that I am the DCP server. Second, it will send the message offer, DCP offer. The DCP server, it will send the message DCP offer, and this message will also be broadcasted. Why? Because this machine doesn't have IP address, so it will be broadcasted that it should be received by each and every one. Okay, and this DCP offer message means that I am DCP server, I am the DCP server. And it also assigns that if I want to assign to you the IP addresses, so it gets an IP address from the free list, from the free IP addresses, for example an IP address, and it send that if I want to assign to you an IP address, this will be the IP address. For example, you can see this is the DCP offer message. The source address is the address of the DCP server. It has the IP address, so it will when it sends the message, so it will have its IP address, and this is the source port number of this DCP server. The destination address, it will be 255.255.255. Why? Because this machine, it doesn't have IP address, so it will be broadcasted, so all the machine will read this message. And the port is 68, so this is for the DCP client. And along in this offer message, it also indicates that if the DCP address say that 223.124, so this is your IP address. If I want to, I have the free IP address and I can assign to you this IP address. So why IP address means this is the IP address that could be assigned to the new joining node. Okay, so why IP address means your IP address. So if I want to assign to you, so this IP address will be assigned to you. When this DCP discovery message was sent, so why IP address was 0, that I have not assigned any IP address till now. Okay, And this is the transaction ID 654. The 654, it is in the Dcp discovery. So through this transaction ID, the client can differentiate that this offer message is for this request, okay. So through transaction ID, the client can know that okay, this is the the message that I have received from Dcp server, it is for this request, okay. So when the Dcp server sends the Dcp offer message, so it includes the transaction ID of the request that was received by the Dcp server, okay. And this is the lifetime, that this IP address, if it is assigned to you, so it will be valid up to 3600 seconds, okay. So within, if you want to use up to this time, okay, it's okay. But if you want to use beyond this time, then the client has to renew this IP address from the Dcp server, okay. So you can see that Dcp offer message, it has the source IP address this, the destination is this, where IP address means your IP address means that this server will assign to the client this IP address, and the transaction ID, it will be same in the Dcp offer message as that was received in the Dcp discovery. Why? Because through this transaction ID, the client can differentiate that I am receiving this offer message against this request message, okay. And this is the lifetime, that this IP address will be valid up to this time. If the client wants to use IP address beyond this time, then the client has to renew it, okay. Now the client will indicate okay that yes, the client will send the Dcp request. So this will be again broadcasted, and it say okay, I got this offer, I would like to take that IP address. So the client, in the Dcp request message, it indicates that okay, that you have sent to me this IP address, I'm willing to use this IP address, okay. Now again, you can see that the client doesn't have IP address till now, so it will be 00. This is the client port number. So this message will be broadcasted, okay, 255 because it will be sent to all the nodes, okay. And this is the your IP address. Why? Because now the client has get the your IP address. Your IP address. So this your IP address will be set here, and now the client is sending the new message. Okay, so in the previous message the transaction ID was 654, now the transaction ID will be 655, and this is the lifetime that this IP address will be valid for this time, okay. Now after this, the client will send the Dcp acknowledgement message that okay, now you can use this IP address, and this IP address will be moved from the free list to the occupied list, that this IP address is now assigned to this machine, okay. And when the Dcp acknowledgement message is received, you can see the source IP address will be same as the data of Dcp server and port number 67, destination this, and this your IP address means that this is your IP address, this is the lifetime, and the transaction ID will be 655 from the last request message that was received by the Dcp server. So through transaction ID, the client can know that this message is received against this request, okay. When this is received, now the client have the IP address 223.1.2.4. so along with IP address, it also receives the subnet mask of this network, it also receives the DNS address, it also receives the default gateway in this network, okay. So these all things are sent in the Dcp offer and Dcp acknowledgement message. So this is that how the Dcp protocol is used by the client and server to assign the IP address automatically to the client by the server, okay. So the Dcp, when it assigns, like when it sends the Dcp offer message or the Dcp acknowledgement message, so along it not only assign the IP address, but it also assign what? It also return the address of the first hop router, that is the default router, the default gateway for the client. It also returns the IP address of DNS server. We have already discussed that DNS server address is mandatory. Why? Because if the DNS address is not present, then the client cannot access the the host through names. Okay, and the network mask. Why? Because this network mask is very necessary. The subnet mask is very necessary. Why it is necessary? Because the subnet mask, when we assign an IP address to a machine, okay, so when we assign an IP address to a machine, we have to specify that how many bits are used for network part and how many bits are used for host part. So this can be specified by using /24 or by using the subnet mask. So normally the subnet mask is used. Okay, so this subnet mask is used that in this IP addresses the first 3 bytes are used for the network part. Okay, so the DCP message, it not only assign the IP address, but it also return the default gateway router, the default gateway address. It also return the name and the IP addresses of the DNS server, and it also return the network mask or the subnet mask. So this indicate that how many bits are used in this IP address for network part and how many addresses are used for host part. Okay, so we have discussed that in the DCP it basically there are 4 messages. One is the DCP discovery, DCP FR, DCP request, and DCP acknowledgement. So we have discussed these messages through example. Okay, now we are going that how the DCP protocol works. So basically the DCP protocol, its functionality is what? It allows a host to dynamically obtain IP address from the network server when it joins. Okay, so as I have discussed to you that what is the advantage, it can renew its lease on address in use. Okay, that we have discussed that when IP address is assigned to a host, that IP address has a lifetime. Okay, or if suppose this IP address is assigned to the machine and after 60 seconds the host get disconnected, switch off. Okay, so when this lifetime is expired, and then the host will not renew it. If the host doesn't renew it and this lifetime is expired, then the DCP server will come to know that now that IP address, that machine doesn't exist. So this IP address, that 223.124, it was assigned to this host, now it is free, so it can be assigned to anyone else. So, and if this machine wants to use that IP address, so it is assigned to this machine up to this time, 3600 seconds. So you can set it like you can increase and decrease this time. Okay, so this is so this host, this IP address 223.124, this is assigned to this client for 3600 seconds. Okay, so if after 3600 seconds, if this client doesn't renew this IP address, then the server will can assign it to anyone else. If the client want to use this IP address beyond this time, then the client has to send the renew address, send the renew message that I want to renew it, I want to extend this lifetime. Okay, so it can be done. So basically the DCP server, it manages the IP addresses efficiently. So when this client disconnects from the network, suppose it is switch off and this time period is expired, then the server can use this IP address and it can be assigned to anyone else. Okay, so it basically assigns the IP addresses more efficiently, it manages the IP addresses more efficiently. So the DCP server, it can renew its lease on address in use. Okay, so it also allows reuse of addresses. Okay, because the IP address is hold for certain time. If that time is expired and the client doesn't renew the IP addresses, then that address can be assigned to anyone else. It supports mobility. Why mobility? Because if you are assigning the IP address manually, so if you are in this client, in this network, so you have to call to network administrator. Okay, what is the IP address, which IP address is free available, and what is the subnet mask, what is the default gateway, and what is the DNS addresses. Now if you are moving it from this network to this network, then you have to again get the new IP addresses according to this network. Okay, so again you will call it. But if you are using the DCP client, so if you are in this network, you will get IP address automatically without any intervention, plug and play. If you move from here to here, then you will get automatically IP addresses. So you don't need disruption. You don't need to manually assign the IP addresses. So and support mobile user, because nowadays due to having mobile or laptops, the people they move from one place to another place, and that is the people are moving from one subnet to another subnet. So using the DCP, now when a user move from one subnet to another subnet, it doesn't have to get the IP addresses manually, but using the DCP server, the client can get the IP address seamlessly. Okay, another important point, that the DCP can also offer security. Okay, how security? For example, when the DCP client it's get the IP address, so this message will also have the MAC address of this laptop, so it can be stored here. Okay, it can be stored here. Suppose this laptop, it is basically someone, for example, lost this, for example, this laptop is lost, and it is suppose another person, for example ABC, it took. Okay, so if that network, if that person joins the network, so its MAC address will come here. So if the first person, a person who has lost the laptop, it communicate to the network administrator that this is the my MAC address. Okay, so whenever someone joins this network with this MAC address, so let me know, because this is my laptop. So okay, it can be also used like this way. Okay, now we are going to extend the DCP example and how it is works. So you can see that suppose this is the DCP server, it is running on, okay, the DCP server application. Okay, this is the DCP client, it wants to join. Okay, you can see that the DCP, it is a application layer. This is the application layer protocol. A transport layer, it use UDP. Okay, at the network it use IP. Okay, and this application protocol is used to get IP address automatically from the DCP server. Okay, so connecting laptop needs its IP address. When this laptop wants to join the network, so it needs IP address. Okay, it needs the IP address, it needs the gateway address automatically, it needs the address of DNS server for this network, and so for this purpose, it one approach is that it gets manually, another approach is it use the DCP. Okay, so this is the DCP protocol. It is the application, it works like this way in the protocol stack. So the DCP client, it will send the DCP request message. Okay, the DCP message request message is delivered to the UDP. The UDP will attach its own header. When it delivers it to IP layer, it will attach its own header. When it passes through the network Ethernet layer, so it will attach its own header. Okay, so the DCP request message, it is encapsulated in the UDP at the transport layer and IP layer and Ethernet address. Okay, now the message is sent. Okay, and we know that this DCP message, it is basically broadcasted at the network layer. It has the IP address, destination IP address is 255.255, and at the LAN layer or at the link layer, it has the destination address FFF. This is the make broadcast address. Okay, so it will be received by each and every machine. Okay, but at the application layer, it will be received. Okay, so you can see that when it is received at this here, so it is received by it. You can know that. Okay, so the DCP message, so you can see that this is the message is received here at the server. Okay, So the physical layer will pass it to the Ethernet will pass to the IP, and IP will pass to UDP, and UDP will pass to DCP. Okay, so the DCP message, the DCP server will read it, that this is the Dcp discovery message. So now it will send the response. Okay, so the DCP server, it basically formulate the DCP acknowledgement or the DCP offer message. So it will contain the IP address, that okay, I want to assign you this IP address. Okay, any, for example, 223.1.1.4 in the previous example. It will also return the first hop address, that is the default gateway address. It will also return the name and the IP address of the DNS server. Okay, so this message will be encapsulated and this will be sent. Okay, now the clients knows that its IP address. So when the DCP client receive this message, so DCP client, it comes to know that about the its IP address, the DNS addresses, and the default gateway and the subnet mask. Okay, basically this is the header of DCP message. This is the header of DCP message option. This basically this can be used that whether the message is DCP discovery or DCP request or DCP offer or DCP acknowledgement. Okay, this is the transaction ID, it is 4 byte. Okay, and this is the your IP address, it is 4 byte. Okay, so there's options. Here we included what is the default gateway, what is the subnet mask, etc. So these options, they are available in this RFC. For example, if the option is 53 and its length is 1, so if 53 and its value is 1, so it means that this is the DCP message request message. Okay, this is the DCP acknowledgement message. Okay, similarly, if we have 54 and 4, so this is the length 4, so it is the basically the server identifier, that what is the server IP address. Okay, this is the subnet mask, and this, so these all options and their possible values, they are defined in this RFC. Okay, so using these option value, the DNS address, the subnet mask, and all other the default gateway, all other things, they are defined here in the option field. Whether it is the request message, whether it is the offer message, it is acknowledgement, and so on. So it is defined here through options. Okay, so this is basically a Wireshark captured messages for the DCP messages. So you can see they are defined here. Okay, you know, this is the transaction ID, this is the client IP address, that is the client has assigned this IP address. This is the next server IP address, option 1, this is the DCP acknowledgement message. Okay, and this is the router address, this is the domain, the DNS name and its IP addresses. They are, this is the name and this is their IP addresses. There are 4 DNS addresses. Okay, now we are going to discuss another important topic, that how IP addresses are actually assigned worldwide. Okay, so basically we get the IP address, we get the internet from ISPs. Okay, we get the IP addresses from IP address. So in this slide we are going to discuss that how IP addresses are assigned worldwide. Okay, so basically we get the allocated we get the internet from ISP. So the ISP, they gets allocated portion of its IP address. Okay, for example, this is ISP's block. For example, in ISP, for example, this is ISP A, suppose ISP. So this ISP is assigned this block of IP addresses, like 223, 16, 20 bytes are network part. Okay, so the remaining 12 bits, they are host part. Okay, 2 to the power 12 IP addresses can be there. 2 to the power 12, suppose. Okay, so this, now this ISP, when the organization wants to get the internet from ISP, so for example organization 0, it is assigned this IP address, organization 1 or 2, 7 and so on. Okay, so basically the worldwide, the IP addresses are assigned to the ISPs, and when the organization gets the internet from ISP, then the ISP assigns the IP address from that block which is assigned to the ISP. Okay. Now another important concept that is about the prefix matching. You can see that, for example, this is the ISP, fly by night ISP. So it assigned these IP addresses to the organizations. Okay. So these IP addresses, all these IP addresses, it can be represented by using single IP address like 223.16.20. So using this single IP address, this common prefix, this is the common prefix among all these IP addresses. Okay. So this common prefix, it will be stored here in a router. If anyone wants to send message to if anyone from the internet, it wants to send data to any host here in this IP addresses, so this IP address will be first brought to this network by using this IP address, common prefix. So here we have, for example, 100 addresses, but for these all 100 addresses we have to store only one common prefix in the router of each in the internet. Okay. So if anyone wants to send the data, so it will be first delivered to this network by using this IP address, and then when the packet comes here, then it will decide whether this packet is for this address or this or this or this. Okay. So this is the we have already discussed it using the subnet mask that we have discussed it as in the it is a more generalization way of this that we have discussed it. If you remember that we have discussed it, that using the network part or the common prefix, we can have the common prefix stored that represents all the IP addresses within that range. Okay. So we have already discussed it. Now suppose that we have in another IP, you can see that ISP are used. So it has two addresses. One is this one IP address. So for this IP address, it is very specific. Okay. So this so suppose it will advertise that send me any message with that begins with 199.30.16. So first 16 bits, this common prefix will be announced to all the routers. Okay. So if anyone from the internet want to send a message and it match with this common prefix, so I have these IP addresses, so it will be sent here, and this is the only specific IP address, not representing all the block. Okay. So this is the specific IP address like 223.18.023. Okay. So this will be so we have already discussed this common prefix through examples. Now how does the ISP gets the IP addresses? Okay. So basically, like as we have discussed, that the organization, they gets the IP addresses from the ISP, and the ISPs are each ISP is given a block of IP address. Okay. Now from how the ISP gets these block of IP addresses, so basically worldwide we have an organization, and worldwide we have an organization. That organization is called IK, Internet Corporation for Assigned Name and Numbers. So this is the worldwide organization. It basically allocate IP addresses, it manages DNS, it assigns the domain name and resolve dispute. For example, if someone have an host, for example, it wants to name it www.yahoo.com, it is already registered, so it will not be assigned. Okay. So whenever you get a domain name, so you have to first verify from ICANN that whether this name is unique, it is already assigned or not. If it is already assigned, then you cannot use it. Okay. And IP addresses, so basically the ICANN, it assigns the IP addresses to the ISPs. Okay. And then the organization or the user, they get the IP addresses from the ISP. Okay. So this is how the ISP are managed worldwide. Okay. So you can see that okay, we are going to discuss another topic, and that is IP address allocation, and we would like to discuss it in the next video. So we would like to stop here. Okay.